In this video, I break down the solution for challenge 3 of Ethernaut CTF. It's called coin flip. So this video is a part of a series of videos for all the solutions of this Ethernaut CTF. So stay tuned for more. And I explain all the reasoning behind the solutions so that you can learn and do it yourself too, right? So hello and welcome to the DecentraWise channel. My name is Pedro, and we share in this channel information about Web3 and blockchain development and security. So subscribe if you like this kind of stuff. So let's get right into it. So we have our Ethernaut page open and the console so that we can interact with the challenge. If you want to learn how to set this up, how to set up MetaMask and everything, we are on Sepolia network, as you can see, the testnet. It's the recommended one. So if you are unsure about how to set up all this, go to the first video in this series and check that out. Okay. So we are going to challenge number 3. So it's this one, coin flip. Let's check that out. And in this challenge, we have it's a game. So it's supposed to be a guessing game, right? And we should guess the correct outcome 10 times in a row without missing one, right? And what does this mean? This means that it's practically impossible for us to do that on by chance. So what we need to do is to find a way to figure out beforehand what's the next value, right? What's the next flip of the coin? So let's see if we can figure something out. So how do they implement this? So we are in Solidity version 8. We have a pretty big random factor there. So we have the consecutive wins so that we can beat the 10 in a row thresholds. And the function we have to call is flip. And the function receives a guess, which is a Boolean value, true or false, right? And it will be the result of this calculation here. So we have block value. Block value is the block number minus 1 block hash. So the hash of the previous block, right? And translated into a uint 256. So, and based on that value, we divide it by the factor. And if it is 1, it will be true. If it is not, it will be false. So how can we beat this calculation, right? When we think about how to break stuff like this, the first thing that we know by looking at the code is that there is a block number and a block hash, right? Which is not easy for us to know beforehand. Actually, it is, because if it is the prior block, it gives us some a few seconds to work that out. But doing calculations by hand could be tricky. So the easiest way is for us to implement a contract that will call this function. And that way we know that we will be on the same block calling this function, right? So if the contract calls this function, it knows beforehand what the block hash of the previous block is, and the factor is a constant factor, so it's easy to calculate, right? So let's go for it. Let's build a contract to break this. So how can we do that? The easiest way to implement this is to go to Remix and create a contract there. So let's do it. First of all, let's get the instance of this challenge to play with. Okay, we have an instance, so let's get this value. We will need this in the future, right? So this is our instance. So what do we need to do? We need to head over to Remix IDE. Let's create a new contract here. Let's call it coin flip attack. I like it. So this contract has, let's start by copying the first lines so that we don't need to type that all. Boom, coin flip attack. Here we are. So what do we need to supply to this contract? Actually, let's bring in the coin flip contract itself so that we have it to have our ABI in place or interface in place. So let's grab it. There we go. Okay. Remix is letting us know that pasting code can be tricky, can be phishing code that steals our funds. So be careful with that. But in this case, there's not a big deal. There's no problem with it, right? So here we are. We have our coin flip contract. And right now, we need to create a variable of the coin flip contract type. So coin flip victim is our victim contract. Okay, so let's do a constructor to initialize this victim. So the constructor receives a victim address and stores it for future use. Okay, that's it. And now, what do we need to do? We need to do our attack. So we have to copy this factor in. Let's bring it in. Yeah, and let's do a function. Let's call it win to be more. I usually call it attack, but this is not an attack. This is just a game, right? So make it fun. So what do we need to do here? We need to do the exact same thing that they do here, right? This. And by doing this, we know that the side we are picking is exactly the same that they are calculating, right? So then we just need to call our victim's contract, right? So victim.flip is the name of the function and pass the side, right? So this is it. We just need to call this 10 times and we beat the challenge, right? So either we do it in the code here or we do it in by hand. It's preferable by hand because then it will go in different blocks and it will be better, right? So actually they have some, as you can see, they have this if the last hash is the same as the one that we get, then it will not allow. It will revert, right? So it has to be done in different blocks. So we need to do it by hand, okay? So let's do it, right? So we have this contract. We can build it. We have, what's here? Problem, spelling helps. What do we have here now? No visibility, sure. Public. We have, this is not needed. So, right, there we go. So now it's okay. We get the block value, we get this, and we pick the side. Okay, it's probably fine. So we have compilation successful. So let's deploy our contract, right? So we need to connect to our MetaMask. There we go. Choose the right contract, the attack contract. Let's put our victim address here. So it's this one, copy string content. Now we can deploy our contract and it's deployed. We have our contract and now we can do 10 times in a row the win, right? So let's check one thing first. Let's check our contract consecutive wins. Yeah, let's do it user friendly. 0. Okay, so Now let's play. Let's go here and win one. And boom, we won one. Let's check it just to know exactly. We won one. So if we can win one, we can win all, right? So let's do it. Okay, it seems that failed. It's too fast, I think. Try again. Why is it failing? Okay, it went through. Let's check out. We have to wait a little bit for another block to be validated. We go. Let's wait a little bit. Go. This is the boring part, sorry. Some strange failure there. Try again. Here we go. Let's see. How are we going? We are 6. Okay. 4 to go. Let's go. Soon. Yeah, too soon. Wasting a bunch of gas just because we can. Here we go. I think 2 more to go. Get out. Oh, just 1. Okay. So let's see. Okay. And there we go. We should be good to win the challenge. So let's see. Submit instance. And we've done it. Okay. So what did we learn from this challenge? Everything in blockchain is public. So everything you store on a smart contract, like the factor or anything else, is public. So everyone can have access to that, right? And also, if you rely on chain variables like block hash or block timestamp or whatever, they are quite easy to predict because you've seen in this challenge, as long as we have the access to those inputs, we can do whatever calculations we want with them so that we figure out beforehand what will be the value. So this has been used in many exploits of many blockchain games in the past. So it's very important to use like Chainlink VRF or any other providers of random numbers so that we don't fall in this problem, right? So this is it, guys. We solved this challenge and hope you enjoyed it and had some fun with this challenge with me, and you learned how to understand this vulnerability in the code and how to exploit it, right? So hope you had a nice time. Sorry for the delay on this challenge, because it had to be every block or try to not repeat our transactions in the same block because of the check that the contract had. And yeah, we won. We were able to do 10 in a row. We could do 1,000 if it was required. Okay, as you can see, this is the kind of exploits that can be done with those blockchain variables. So don't rely on them on your contracts, right? So hope you had value from this video. Hope that I could teach you something, and go do it yourself and beat the challenges of Ethernaut CTF. It's a fun way to learn about blockchain security, and I strongly advise every Web3 developer to go through these challenges from time to time. So if you like this kind of content, do the usual, like the video, subscribe for more videos, and thanks for watching, and see you in the next video. Cheers. Bye-bye.